So I'm going to start with a little bit of a story, which happens in 2021. So imagine that we're back in the time when the pandemic is raging, you're all sitting at home quarantining, and your boss approaches you on Zoom and tells you that the rest of your organization is trying out this build tool that Google developed, and it's showing a lot of promise. And you're a web engineer and you know nothing about this, but you're very excited to try it because there's promise that your developers will be more productive. So that's where we started in late 2021. Airbnb began its exploration into Bazel. Mainly, we took things off the shelf. So we started creating prototypes using open source tooling. And then in early 2022, we were a little bit more comfortable with Bazel itself. So we started writing our own custom rules. And we did this because the open source tooling didn't really work the way we expected. So we moved towards doing things a little bit differently. And namely, we approached this by tarring and pruning all of our inputs. So we just figured if there's less code, our Bazel builds will be faster. And we were mostly right in that regard. And things were fast enough to ship our type checking and linting for web with Bazel. So then late 2022 came around and we started this saga of working on unit testing. And we realized that just tarring up your inputs is not good enough to make our unit tests fast. So we added a layer of caching, and specifically this layer of caching was on our remote workers. Well, that wasn't really fast enough either. So we're in our present day now, and we now cache our dependencies in Docker, and our unit tests are almost fast enough to ship. And I'll get there at the end of this, but this is what this whole thing looks like end to end. And this particular chunk this year is our Taming node modules era. So we were just tuning node modules throughout all of these 12 months, trying to figure this out. So my name is Sharmila. I'm a software engineer at Airbnb, and you know how the last 2 years of my life have been. So I feel like I can get into the real topic here, which is taming node modules in remote build execution. And if you don't know what node modules is, it is the directory that houses all of your third-party dependencies for any Node.js or JavaScript project. And if you don't know what remote build execution is, why are you here? No. It's a Bazel feature that will let you run actions in a distributed way using remote machines. It's really great for large organizations where everybody's doing similar things because you can share a layer of caching and have some really robust parallelism. It's been working great at Airbnb. So I'm going to talk about two things: handling node modules in RBE, where I'll spend the most of my time, and then what's next for us in our Bazel migration. Before I get into anything, this is how big our node modules are. So we have about 3 gigs worth of third-party deps and about 250,000 files. And on average, I would say if you look at a really long length of time, this changes about 5 times a day. But it really comes in waves. So sometimes it's more than 5, and sometimes it's once a week. It depends on what our developers are doing, and that's hard to predict. So where were we in late 2021 when we were new to Bazel and new to this entire ecosystem? We had a lot of challenges with sandboxing. So this particular file tree is the smallest target in our repo. So it's called isEqual. It's just a utility that'll tell you if 2 values are equal. And this is something you need if you're writing JavaScript. And this is the resulting sandbox for one of our unit testing targets. So if you notice, there's a few things that seem a little fishy. So the first thing is 38 out of 39 of our sandbox, or megs of our sandbox, is this manifest file. So the tool that we were using at the time would actually override node's module resolution and kept track of all of the resolutions inside of this file. So you end up with this big giant manifest file. And then about a meg's worth of node modules itself. So none of this is coming from our isEqual package. This is all just the things that we need to test that particular package. About 12 kilobytes of projects. So this is our internal projects now, the things that we need to run our tests. And Overall, it's just a lot of things, and there's only 4 files because the majority of the sandbox is symlinks. So if you can imagine, if any of these things are running remotely, we would have to send all of this up the wire and then set it up remotely. It takes a long time. So ideally, every job inside of our repo is allowed a maximum of 15 minutes. And when we first tried out Bazel, we were essentially breaking that budget by quite a bit. Our type checking job took about 35 minutes, and unit testing, honestly, it's 60 plus because we were never able to run all of the targets in our repo. The resource consumption was just so high. And when we did, it was just easily maxing out beyond 60 minutes. So we decided if we just reduce the amount of files that we're sending over the wire and prune out anything in our inputs that we don't need, we can make the sandboxing step a lot quicker. So we did that. This is just very roughly how we did it. So we would essentially have the package manager first lay out our third-party deps for us. And then we would create tarballs out of this, and then send these tarballs off to remote, and we would untar them in remote, and then either run, whatever process we're trying to run, just as our unit testing tool, and TypeScript, of course, is for type compilation. And here's what an example node modules package looks like. That package JSON is not an OCaml package JSON, it's JavaScript, in case that's confusing. And this is actually a popular package that I just changed the name of and some of the directory names. But if you notice, it ships with all of its tests, it's shipping with its mocks, it ships with documentation, and this is very common in the NPM ecosystem. And what we do is generate a bunch of build targets that will output this particular tarball. So instead of shipping loose files or sending them to remote, we're just sending one tarball up to remote. We were really smart about this when it came to type compilation, because we knew that we don't need the majority of what's in this package. So what we could do is just cut out everything we don't need. Here it's all of the JavaScript files, the documentation files, and what you end up with is a much smaller version of that particular package, and it's laid out the same way. So we have a Bazel target that will generate now a tarball for TypeScript itself. So here's what the performance impact looked like on type checking. It is just falls completely off a cliff. So once we've pruned our inputs, we're untarring things that are a lot smaller in remote, and it's much quicker to actually run TypeScript or get to running TypeScript itself. So we saw on average things go from about 35 minutes to well under our budget. So now it's around 12 and a half minutes on average. So we're good on the type checking front. We're under 15. It's actually faster than the native tool as well in a lot of cases, especially when the cache is warm and your developer has just made a code change. But the same strategy for unit testing didn't quite pan out. We were still kind of 2x over our budget, and it just felt like there's more we could do there to make things faster. So we decided if we're spending all of our time untarring packages once we're in remote, why not cache whatever we have already on a worker and compromise a tiny bit on hermeticity and determinism for the sake of speed? So we did that. Essentially, we were working with 2 different locations on disk. The first is the execution route, and this is where Bazel will run your actions from. It's Bazel's working directory. And the second is the worker cache. And this would be any location in your remote worker that is outside of the execution route that your actions can reach into and is visible to these actions. So inside of this worker cache, we lay out node modules in a very specific way. Here it just lives in temp. And this is a directory tree, by the way, or a file tree, rather. So the temp node modules cache is your parent directory. And then underneath that, what we have is actually the content hash of a tarball. So whatever tarball we send up the wire, we take the SHA-SUM or SHA-256 of that, and that becomes where we put things in our worker cache. And then underneath that is just itself, which is the node module that we use for unit testing. In our execution route, we just lay things out the way that Node.js expects it to exist. And here, just is not really existing in this route. It is going to be a link to the worker cache. So when we're running our action and we actually don't see this package in our cache, we will untar it into that location and create this link again. So as you can imagine, this had a lot of limitations. This particular graph at the top is the teal line is all of the available workers, and the blue line is all of the busy workers. So if you can tell, when we scale up, like once our autoscaler puts a bunch of new workers in the pool, our cache hit rate drops. And this is very expected. We knew this was going to happen. And this also had an impact on runtime. So this graph should look very, very similar. As our cache hit rate drops, all of a sudden, instead of spending seconds to set up node modules, we're spending 3.5 minutes. It just becomes kind of an untenable overhead. If you can tell, this one's a little bit like of a lagging indicator, like we go up and then this graph goes down. And here it's the opposite, like our cache hit rate drops and then our runtime spikes. So it made things a little bit faster. I think we had like an 8-minute on average drop for unit testing from 30 minutes to 22, but we're still not under that 15, which is where we want to be. So we decided when a worker starts up, it should have some version of node modules in it already, so we don't have this problem when we auto scale. Well, okay. So we wired this up in such a way that we tell our remote execution platform what we want to do with this particular rule. And here we're just using a field called exec properties. We're giving Jest its own pool of workers, and we're saying that we want to use this Airbnb Bazel Docker image, and this Docker image is going to have node modules in it already. I know that if you use any like third-party remote execution platform, they're going to have a very similar API to this. And our cache changes just a tiny bit. So we've just added this thing in the top right corner that is teal, if you're not colorblind, called the Docker read-only cache. So we've just added a third layer of caching, or a second layer of caching, and it's going to be exactly the same. So we again have like the hash of the tarball under our cache, similar to our worker cache. We keep both around, and our execution route is going to be laid out the same way as well. So here, the only change that we make is we just check to see if this particular package is inside of our Docker cache, and if it is, we make a link. And if it's not, we check our worker cache. If it's not there, we'll untar it into there and make a link. So in your exec route, you don't really have any node modules that are like present. There are always links to one of our cache directories. This was a lot more challenging to set up than the 2 slides that I just showed you. We ran into a lot of issues with making our tarball SHAs deterministic. And I think at one point we had a deterministic SHA between 2 distros of Linux and a deterministic SHA between like local Mac and local Linux. But CI and local would never have the same one. We had to do a ton of work to like normalize like metadata fields on the file, make sure like all the files are in the same order in our tarball, make sure the mode that we're trying in is the same, just to get this to be consistent. And then we have packages that compile down to native binaries. And these are definitely just going to be different based on the environment that you're running in. The way that we handle these is that we only create these binaries inside of the platform that your action will be running in. So we never send them up the wire. And this has this added benefit of the SHA being platform independent. And then once we're in the platform that we know your action will be running in, we create this native binaries. They're also cached in our Docker image, and we can sort of treat them this way. They're a little bit special. We're still working the kinks out with that. And then the last thing, so if you've been following me this far, you're probably like, okay, you took this 3 gigs of node modules and stuck it somewhere else. So like, how slow is your Docker pull times now? Well, honestly, the way that we were dealing with image thrashing, it's a little bit more of an art than a science. So what we do is we update our Bazel configuration once a week on a Friday night at like 10 p.m. when most of the world is on the weekend and our developers are not making pull requests. And then the idea is that by the time they come back to work on Monday, they have a bunch of warm workers with no new node modules, and things are fast and good. So the result of this was pretty compelling, I thought. So our node modules prepare, the cache hit rate just goes up and just stays up. We never drop we never drop below 99% anymore. And then the impact that this had on runtime is also pretty great. So this just completely falls off a cliff. We don't spend minutes unpacking node modules anymore. Maximum is like a few seconds. Like I think the max I've seen it is like 5 to 7 seconds. And then remember this graph, because the next one's not as gratifying as this one. So our job is a lot faster than that 22 minutes. However, we're still not under 15. And yeah, I got to pitch this to my boss, because that's a new way to look at this. Yeah. So the reason for this is that node modules is a small part of this. I think rolling this out, we still have a lot of challenges along the way. And I'll enumerate some of these. We're kind of getting off topic with this. But our builds are just not very granular. Actually, it's a non-trivial thing to add build granularity in our repo, because we do have a lot of cycles in our code. We have Bazel-specific test failures that we have just been accumulating, because JavaScript or Node.js code, you can very easily bring in dependencies using like a file read anywhere in your code. And Bazel needs to know about these. So majority of these are implicit dependencies that are just missing. Some of our tests are really slow and really memory hungry. So we need to do something about this as well. And the last thing is that we spend a lot of time running Jest, and then Jest will transpile our code before running our tests. So ideally, we wouldn't be doing that action over and over and over again. We should pre-transpile, cache that layer, and then when Jest runs, it should just work on that particular output. One thing that's missing here actually is that we don't really have a good dev experience for Bazel and testing yet. And that's another maybe challenge that we need to address. So given all of that, what's next for us? Well, we're going to continue migrating jobs in CI and get that Just job below 15 at the least. And then so far, we have been telling developers to just use a native tool unless they really need to, like maybe they're refactoring something across lots of files, and Bazel's caching is really useful there. We just let them use the native tooling in most cases. So we need to figure out a strategy to like socialize and standardize Bazel development in local environments for our developers. And I think a lot of them, they don't really care about like learning the ins and outs of Bazel. Like they just want to run something that works and lets them ship their code. So getting Bazel to that point where it's understandable is going to take some legwork. And then lastly, we just really want to give back to the community, whether it's through knowledge shares or contributing to open source. We're always looking for opportunities there. And then these are all of the lovely people on my team who made this a reality today. Bree, Joe, Madison, myself, me, and Bree are at this this meetup conference. Yes, come say hi. We're very easily excitable when it comes to developer experience, dev productivity stuff. Yeah, you can tell. So yeah, that's all I have. Thank you.